Consider the function f of x equals 2x cubed plus 15x squared minus 84x plus 10 on the interval from -8 to 3. This function has an absolute minimum value equal to, it's two different questions here. Online, these comes up as blanks, and an absolute maximum value equal to, and then there's a blank to enter that. All right, so finding absolute minimums and absolute maximums. If we have the graph, you really can just look and say, all right, so right here, this is clearly the absolute maximum. So on this interval, interval right here, which technically should be a closed interval. I tend to prefer them using closed intervals because that guarantees that absolute minimums and absolute maximums exist. But never mind that. All right, so this is clearly the absolute maximum, and this is clearly the absolute minimum. The question is, look at this scale, 145.8, 291.6, like how in the world would we determine where this point is? We could estimate it, but we can't really determine it all that well. One thing we could note, however, is it happens to be occurring when x is -7 and the minimum is occurring where x is 2. So what we could do is determine what those values are by just simply plugging in to our function the -7 and the 2. So that's one way. So 2x cubed plus 15x squared minus 84x plus 10. All right, I'm going to use a table. So I'm going to make sure my table is set up properly, and it is not. All right, now I want to evaluate this at -7 and at 2. So 647 and -82. So our absolute maximum is the value 647, and the absolute minimum is the value, what did I say, -82, I think. Double check that. Yeah. Now, if you're wondering how could I have gone about this and determined these two values here, -7 and 2, without the knowledge of the graph. Well, you could have done that by taking the function itself, finding its derivative. So that would be 6x squared plus 30x minus 84. And then if you take that derivative and set it to 0, what that does is it locates critical values for you. So it would find wherever you have horizontal tangent lines. And absolute minimums and absolute maximums, if they occur on the interval, they're going to occur at critical values. So you could potentially factor this polynomial. Let's see, probably could do that. Let's try it out. 84 divisible by 6. Yes. All right. So this I could write as x squared plus 5x minus 14, I think I did. Yeah. And that will factor x and x, 7 and 2. That's positive and that's negative. That reveals I have horizontal tangent lines at -7 and 2, as seen in the drawing. So absolutely could do it without the picture.